Convince me that the absolute maximum of the function g on the closed interval negative 2 to 2 is 6. Now, how do we do that? Well, we know that the maximum is going to be 6, so that's something that we're looking for, and we need to make sure we go through the steps that are necessary. We know that whenever we're trying to find maxima or minima, our first step is that we want to find that first derivative. And so I'm going to write that out. We'll do that in red. Find critical points using f prime. Or in this case, sorry, I shouldn't say f prime. What's our function? It's g, so g prime. So g prime of x is going to be 6x squared plus, bring down the 2, so that's going to be 3x minus 3, and then minus 0 because the derivative of a constant is 0. So there we have our derivative. And the way we find critical points is that we set the derivative equal to 0. 0 equals 6x squared plus 3x minus 3. I'm going to divide both sides by, everything by 3. So I'm going to get this equals 2x squared plus x minus 1. In this case, what I can do is I'm going to factor out 2x squared plus x minus 1. Since 2 is a prime number, I can't really do much with it, so I just have to say 2x is one of them and x is the other. And I need to figure out and then minus 1, the only thing that's going to make that happen is negative 1 times positive 1. So I just need to figure out where am I going to put my negative, where am I going to put my positive. Here, this works because what we can see is we're going to get minus x, but plus 2x. Negative x plus 2x will give us this plus 1x that we want. So this factor is right. And what we need to do next is we need to use the zero product property to figure out where those critical points are. It'll be at 2x minus 1 equals 0 or x plus 1 equals 0. I'm going to add 1 divided by 2, so x equals 1/2. And here, subtract 1, so x equals negative 1. These are our two critical points. Now, the next step that we need to do in order to figure out where the absolute maximum is we need to plug in crit points and endpoints into our original function, g. And where do we get those endpoints from? From the interval. We want to see what's happening at the ends because maybe something funky is happening there that would make it rise even higher, but not have a derivative that is 0. So we need to find what g of 1/2 is. We need to find what g of negative 1 is. We need to find what g of negative 2 is. And we need to find what g of 2 is. So we need to find each of these values. G of 1/2, we're just going to plug in 1/2 into the original function. So 2 times 1/2 cubed plus 3 over 2, 1/2 squared minus 3 times 1/2 minus 10. What I'm going to tell you is that this is probably going to be some negative value, right? Because 1/2 to the power of 3 is 1 over 8, and so 2 times 1 over 8 is just 1 over 4. So this becomes 1 over 4 plus 1 over 4. This 1/2 squared is 1 over 4. 3 halves times 1 over 4 is 3 over 8 minus 3 halves minus 10. These are all tiny fractions, and then we get this negative 10. So it's going to be like, I don't know. I'm going to make this up. It's not exactly right, but if I need to check it later, I will. So that's negative 8. Cool. Now let's test negative 1. 2 times negative 1, I'm going to say approximately negative 8. 2 times negative 1 cubed plus 3 halves times negative 1 squared minus 3 times negative 1 minus 10. Negative 1 cubed is negative 1, so 2 times negative 1 is negative 2. Negative 1 squared is positive 1, so plus 3 halves plus 3 minus 10. 3 minus 10 is negative 7, minus 2, negative 9, plus 3 halves is like negative 7.5. Okay. G of negative 2. What about that one? So let's plug that in. 2 times negative 2 cubed plus 3 halves, negative 2 squared, minus 3 times negative 2, minus 10. Negative 2 cubed is negative 8, so this becomes negative 16. Negative 2 squared is positive 4. 12 divided by 2 is 6. Plus 6 minus 10. And so Negative 16 plus 6 is negative 10, plus 6 is negative 4, minus 10, negative 14. I believe. Hold on, let me figure this out. Let me make sure. Yes, minus 14. Okay, so we're getting lots of negative values. Let's see which one of these is going to be the highest. Let's test g of 2. 2 times 2 cubed plus 3 over 2 times 2 squared minus 3 times 2 minus 10. I don't see my 6 anywhere, which is getting me a little stressed out. So let's see if we get it here. 2 cubed is 8. 8 times 2 is 16. 2 squared is 4. Times 3 over 2 is 6. Minus 6. Minus 10. 16 plus 6 is 22. Minus 6 is 16. Minus 10 is 6. And there I see, there's our maximum value. And I see that the maximum value, the absolute maximum, happens at the endpoint x equals 2. And that value is 6. You've convinced me.